Hi everyone, Aaron here from VitalPoint AI, and today we're going to walk through the MultiSig contract, which is near a core contract, as we have gone and rewritten it from Rust to AssemblyScript. So what you see on the screen here is an overview of what the MultiSig contract does, and we're going to go through that before we jump into the code. Before we initialize this contract and deploy and initialize it, we're going to want to collect a couple things. First, we're going to need the public keys of any of the accounts that we want to initialize it with, and we need to decide how many confirmations we want before some request or action is going to execute. So for example, if I want to deploy a multi-sig contract that has 3 participants represented by 3 access keys, and I want at least 2 of those people to send confirmations before any action will execute. So in other words, we want 2 of the 3 persons using the contract have to agree on their request before something actions. So knowing that, we can then move to deploying the contract, and we'll do that. Typically, we can do it at the front end, but we'll also use near REPL in order to call set some variables and call the function there. I'll cover that in a bit, and it's in the tutorial as to what those commands are. But essentially, we are setting the receiver account, what account name of the contract account we're going to call, putting some arguments into an object, and then we're calling transactions to basically create the contract account, transfer some funds to it, add the 3 function call access keys that we want to it, each with access to the method names we specify, which in our case here would be add request, delete request, and confirm, and then call the initialization function init contract with the number of confirmations, which we decided was 2, in order to set everything up. So that's step 1. Step 2, when we did the initialization, as I mentioned, we added 3 function call access keys, and we gave them permission to access these 3 methods on the contract: the add request, delete request, and confirm. There are other methods that we could add, such as add request and confirm, which puts the add request and confirm into one step. But for this example, we'll separate them out into these 3. So now that the contract's deployed, initialized, has some access keys, 3 of them which represent 3 users, Alpha, Bravo, and Charlie here, we move on to the step 3, where user Alpha submits a multi-sig request, and because it requires 2 confirmations, in step 4, Bravo and Alpha both give those confirmations, which then trigger the execution function for step 5. When the request executes, it performs whatever actions were sent in as part of the multi-sig request, and this contract's been set up to enable several lower level actions, including transfer, create account, adding and deleting keys, function calls, and then we can also set a new number of confirmations on the contract and set the active request limit, which determines how many requests can be active in the system at any one time. All right, so that's a general overview of what the multi-sig contract does. And of course, that's useful in any case where we want to do some kind of action, but want a few different people or different access keys involved in making the decision for that thing to happen. If you think of a DAO situation, it's essentially how a DAO works. Basically, a proposal is submitted, and then people vote on whether to pass the proposal or not. And given NIR's account keys and access keys and the way these permissions and things are set up, it provides a nice structure to create that kind of system. So from there, let's jump over into the code. Alright, so here we are inside the MultiSig contract code. Again, here's our folder structure. The contract, we have the AssemblyScript contracts in this directory here. Some tests, which we won't cover in this video, but potentially in the future. And then we got the main files here. Again, separate out types, data models, and then the main contract, which we put in the index file. Starting with the types, let's take a quick look there. We've just exported 3 types that we'll use in the contract. Request ID of type U32, count ID, and a public key, which is a uint8 array. From there, moving into the models and the structures that we've set up. We've got a function called permission class. We've got a MultiSig request action enum. And if you're comparing the AssemblyScript contract to the REST contract, you notice a big difference in how this is set up, in that we can't, I don't know if it's called embedding or what, but attach arguments and functions within the enum. We got to keep it fairly simple here. So it caused some changes in how the execute request function is set up in the AssemblyScript, which we'll check out in a bit. We have the MultiSig request itself. And this is also different from the rest in that these are present in the REST contract, and all the rest of these would have been defined up here in the enum and then actioned as an action as part of the execute request. But here we're collecting them as arguments and then and actioning them through a switch statement. So that's the MultiSig request. We have the MultiSig request with signer, which just includes the signer's public key. And then we have the MultiSig contract itself, which is what we initialize at the beginning to hold all the goodness. And those are the structures that we'll be using. Moving over to the index file. So first off, we import the types and the models that we defined and are going to use here. We set 2 constants, one being the default allowance if it's not specified when we're adding a key to the contract, and the other being a cooldown period. So once somebody submits a request, it's got to live for 15 minutes before a request can be submitted to remove it. And then we set 3 structures to collect request IDs in different formats, and that's so that we can provide this information at a later point. And then we set a variable for the contract, and then we initialize it. So this is the initialization function. We're simply passing in the number of confirmations, and it sets everything up. So we have a contract structure that we can use. This is the add request function. Does a check initially to ensure that the predecessor account matches the current sender account, so we got no funny business happening. And then we do some tracking, see how many requests this key has made, and then we add the request. And very straightforward. I had mentioned before, this is what we had initialized the contract with the add request method here, but we also have this add request and confirm method that we could have initialized or given permissions for the access keys to use, either in lieu of or in addition to the add request. But this simply combines the add request and confirmation period or confirmation request together, and essentially skips a step, because one could probably assume that whoever is submitting a request is also going to confirm it. So that just combines them into 2. It's not necessarily always the case, but that could be a little bit more efficient there. From there, we also have a delete request function that somebody could submit a request to do. Again, just checks to make sure it exists before it make sure it exists, make sure that it's not outside or less than the cooldown period, which we said was 15 minutes. And then if all that stuff checks out, it pulls the request out of all the structures. And then we have the meat of it. So once we hit the number of confirmations for a request, we have the execute request here. So it requests the MultiSig request that has been submitted to it. It creates a promise which, does a number of actions depending on what actions were part of the request there. So this switch statement looks through, matching up whether it was a transfer, create account, deploy account, add key, delete key, function call, set number confirmations, or set active request limit, and then executes the appropriate code and actions depending on what actions were sent. Key to note, it's going to loop through all the actions that were sent as the array when this function was called, which means you can create complex scenarios where you're calling multiple actions. So you can create an account, transfer something to it, deploy some contract code to it, add keys, and you can do all that within one contract promise batch. So it'll do that and finish up when it's done. Next up we have the confirmation. Probably should have skipped down to this before doing the execution, but again, you got to get the number of confirmations required before a request is going to execute. So this is the confirm function. First off, is just confirms that it is a valid request that we're looking at. Make sure it exists. That hasn't already been confirmed by that particular public key, and if all that checks out, then it goes ahead and executes the request. All right. A couple helper methods here. We have this is init, so if we need to check to see that the contract has been initialized. We have the remove request internal function here. So it'll remove any confirmations and the number of requests if required. We also have a assert valid request, which is a check that we wanted to make sure that before confirming or executing that we're working with a valid request there. So a couple of assert statements and conditions that make sure that happens. And we assert the self request. So this prevents a request from approving a transfer on another account. So it's only going to work excuse me, when the receiver ID is equal to the sender. And the last two actions that we were up in the execute request, the set number of confirmations and the set active account limits, are things that have to happen only one action at a time. So this ensures that is the case if those two are called. So here's the set number of confirmations. Again, it just asserts that it's the only action that's in the array at this point. And same thing with set active request limit. And then we have a number of view methods to get some information relating to the contract. So we can get some information on a specific request ID. We can get the number of requests. We can get a list of all the requests that are in there. We can get a list or all the confirmations that have been made, the number of confirmations, and then what nods we're at, or what the next request ID is going to be. And that's the gist of it. So that is the MultiSig contract. As I mentioned, there's some huge potential for what it could be used for. Just think of any situation where you need multiple people to come to some kind of consensus on something, and you could probably extend this contract to meet that need. Thanks for watching.